Sorry about that. I finished the video before or I got out of the video software before I was able to do question 77. So this is question 77 in the textbook on page, I'm not there yet now, on page 162. So when doing this type of question, you do need to know how to name your acids, your binary acids and your oxyacids. So that's what this question asks you to do. First is to identify which of these acids, and we know they're acids because they all contain hydrogen and at least one other element, sometimes two, sometimes three. So first they want to identify which ones are binary and which ones are oxyacids, and then they want you to go ahead and name them. For the oxyacids, they want us to name the anion before we actually do the name, and I'll explain why they want us to do that. They're just taking us step by step in the naming process. So first of all, you are going to want to, unless you've memorized this, you don't need to. It's going to be on your study sheet that you are given for your test, so you don't have to memorize this. But this is found on page 152 of the textbook. And you will also want to have the common polyatomic ions table also close by. This is going to be page 143 in your textbook. Again, though, the polyatomic ion list is also going to be given to you on that formula sheet for your test, so you don't have to memorize those either. So let's first go ahead and identify which are the binary acids and which ones are the oxyacids. Binary acids are the easiest because it's only two elements. It's going to be hydrogen plus another element. So it's really only this one that is the binary acid. All the rest have hydrogen and oxygen in them, and there's more than two elements. So the rest are all going to be your oxyacids. So I'm just going to put an O for that. So HNO2, hydrogen and oxygen. Here's your hydrogen, there's your oxygen, hydrogen and oxygen. Those are your oxyacids. Binary acids are the easiest to name, so let's go ahead and do that. And following the naming convention, binary acids always start with hydro, and then it's the base name of the nonmetal, which in this case is the base name is iodine. And what they say is to drop the ending and add ic. So this is going to be no space, hydro iodic acid. Hydroiodic acid is this binary acid right here. So just following that name convention is how I got this. Hydro in front, added by the base name, take off the INE and put in IC. Now for oxyacids, it all depends on the name of the polyatomic ion in which the hydrogen is bonding to. So the first thing you need to do is you need to name this polyatomic ion, which is actually the anion in the acid. So this is your acid anion, is these polyatomic ions right here. So looking at your table on page 143, you find out that NO2, the name of its anion is nitrite. And then in this one here, SO4 is sulfate. And then this one right here, NO3, is nitrite. So there, I've gone ahead and I've named all the anions in the oxyacids. Now the reason why I do that is because the convention for the name is to look at the anion, and if the anion ends in ITE, you are going to use the base name of the oxyanion and the acid, and if the anion ends in ATE, it's going to be the base name of the oxyanion plus ic acid. So I think I'm actually missing a little bit of that. Oh, just a second. I feel like I'm missing the bottom of that. Oh, yes, I am. This should be plus us. So ite becomes us and ate becomes ic. I'm just missing that bottom part of the diagram, so just watch out for that. So let's go back up and we're going to look at each of these polyatomic ions and how they end. So for this first one, I have nitrite, so that's going to follow the ITE, so it becomes nitrous. So this becomes ite becomes us, so we get nitrous acid is the name of that oxyacid. For this one here, H2SO4, we have sulfate, so we're going to follow the ATE convention. Ate becomes ic, so I'm going to have sulfuric acid. And then the last one, nitrite, my anion ends in ITE, so this is going to become, oh, actually I think I named that incorrectly. I have nitrite. Oh, one of them is nitrite and one of them is nitrate. That one should be trait. Sorry about that. And because it's trait, it's going to be nitric acid, following that name convention. So it's really important when you're naming the oxyacids that you do name the anion correctly from the polyatomic chart. Then look at how that polyatomic name ends, and if it's ite, it's going to become OUS, and if it's ate, it's going to become ic. So sulfate became sulfuric, nitrate became nitric, and nitrite became nitrous. So that's how you name your acids. You have to identify whether they're binary or oxyacids and then use the naming convention for each. So I hope that helps. If you have more questions, please let me know. Bye for now.